Okay, so I haven't used Solidcam for a couple of months, so need to kind of go back through the process. But one of the things about Solidcam is when it first opens, and you give it the module that you want to program in, it asks you if you want to save internal or have an external file, and it goes ahead and creates that for you. So let's see, we had the gusset. The cap would be okay, I guess. And it has the reference. All right, so one thing with Solidcam, the mold making tools, the eye machining, the high speed machining is pretty nice in its capabilities. So let's go ahead and zoom out. All right, so I tell it it's a Solidcam part. We're going to do a new milling operation, and either this one has run or it's going to come up. All right, so it's set to default, and it's telling me that it's going to create the cam as an external as opposed to saving it into the part file. So the previous cam and HSM both saved their data as part of the solid part file. And so as we go through and make that pick, it's telling me what units were in inches, even though the base was in metric. And then the CNC machine, yeah, let's go with the Haas 3-axis. If we set up a coordinate system, so let's get that in. All right, so when I go to a coordinate system, we're doing the same types of things. We're establishing location of 0, 0, 0 that the rest of the datums can be established from. We're telling it what kind of stock we're working with, and then going through the process. All right, so they have the machine coordinate systems. So number one, if I go to select a face or define, and if we go to the origin, all right, not seeing the preview. It's asking for the X direction, and then asking for the Y direction, and then we should be able to flip around X. Nope, not quite. There we go. So getting our coordinate system into location on one of the corners of the part, and then we can accept it. All right. Tool start levels. All right, so these are all of the defaults, and will show up in the operations later. I don't want to go through all of those. We go ahead and accept. It should jump over now and says you have a coordinate system. We go ahead and accept it. Then the stock, defined by the box, the model, and then relative to the model. So we'll make the CAD selection and resume. See if it found it. So it has that oversized stock. All right, so the only one that we set the 0, 0. The only one that really kind of annoys me is the Z, because I like to see my Z depths from position and set it at the control to go a little deeper. So the Z plus, I would go with a 0, and then we can go ahead and accept. All right, so program numbers 1000, the machining database. We're not really doing eye machining on this. And the machining level is the aggressiveness from 1 to 5, I believe. And 5 being the most aggressive is going to try to remove as much material as quickly as possible. So let's see where that gets us. All right, and then over on the task pane, we have the have some templates. So this is new for 2018. I don't remember this from last time we used it in 2015. So if we take a quick look at the settings, then all of our items are in the background. And there was only 1 or 2 that I wanted to check real quick. No simulation, cam directory. All right. So a tool library. So like we had previous, if I wanted to set up tools, then we can add from the list. We're going to pick an end mill, the diameter, let's see, where is, I was thinking that we would be at the library. Alright, so let's just go, well, as small as it is, the 1/4 inch is probably about right. And then tool data, so we can build in those feeds and speeds for the tool. So 40 inches per minute on the X and Y, 32, 12 for the feed. Those don't look too bad. The eye machining data, holder geometry, different shapes. Do we want coolant? The tool presetter, and if we're going to include any kind of message. Alright, and then if I save and exit or save, if we just save, it's going to say, you know, add the next tool, or we save and exit. Now I have a tool, I have a setup, and we can start looking at the machine processes. So let's see, from the 2.5D, let's just do a facing operation, and we'll kind of pull this one back a little bit. Alright, so same types of interface. There's always going to be something that is going to allow you to make those selections. The geometry was the face mill. So let's show the selection. That was what it picked up, the perimeter of our geometry. The tool, and go back and select from the library. Once it's been picked, if I need to override, I can override any of those geometries. And then if there's a save tool change position, the levels, and this should all be 0 because we're just doing that facing operation. All right, the technology is how we want it to make the pass. So the hatch is the zigzag, contours, round and round. And then how it, it jumped over the other one already. So one pass if it's wide enough, and then a spiral so that it has that, again, that consistent tool load. All right, so the approach to roll or the advanced to sort. No real linking lead-ins. And then motion and miscellaneous. So if we save and exit, it should output, and then we have the same. Oh, maybe I didn't calculate it. That's all right. So we go back and edit. There's another step here. So we have the save and calculate related operations in parallel. And then using items and time calculation. Let's just save and calculate. And then we have the preview of the geometry. And then let's see, we did countersinks on those. Okay, so we'll go with, let's see, try their drill recognition. So on the geometries, let's see how it does. Oh, actually, it's not giving me anything in the list. All right, now I didn't set up any tools on that one, so let's just exit. And we'll go for the drill. Okay, so countersink. Stay with the wizard. Not sure if I need to pick or if it's going to recognize it. Alright, one spot, two drill. Yeah. Alright, so I'm gonna have to look at the wizards. I haven't used those enough apparently. Alright, so If we go back to the milling operation, then there's everything that's available. We go to the drills. Oh, I haven't set up any of the geometries. All right, so I'm getting ahead of myself. All right, so process. We need to add a geometry, add the drill, and then it picks up our coordinate system, and looks like it found or if it left over. So let's go ahead and see if it accepts it. Alright, so we got into the slot. There it is, CAD selection. Alright, so we got one of the points, all circles by radius. Alright, so we got one. Okay, so other than it being subsurface, we'll pick that up with the clearance, and that should give me enough to add the drill. Okay, so there's my drill, and then the tool. We need to select, since I didn't add one to the list. I need to add to the group, pick up the drill. That's still staying with the 1/4 inch, which I think was okay. A little fast on the feeds, shape, coolant, and then we'll select it. And then the levels. So the upper level, it went to auto. And then by depth, it should find the end of the feature and go to the cutter tip. So I'm still concerned about it being sub-level, so 2 inches. Default shortest distance, G81. So let's go with a G83 PEC with retract. Now we'll see what that looks like. Oh, I didn't calculate it again. All right, so it did try to go to the full 4 inch, and we got enough clearance. So on the levels, drill depth. All right, so to the 10 millimeter, you can pick the edge. Need to calculate it, and then save and exit. All right, so we have something that's a little shallower, not so aggressive. All right. So let's see. We need to get over to the post. So if we generate the code, then pretty much this is what it's outputting. Very similar to what we've seen the CAM and the HSM do. We get the output, and then we're pretty much ready to take it out the machine, see how it runs, prove it out, and debug. All right. So again, just to kind of give you an idea of how some of these geometries are generated, programmed for. If we set it up on a manual, then I'm going to be doing the same types of operations, maybe different tool selections, more efficient for the manual operations, but it's going to give me the desired result. Okay, I guess I should have recorded that, or I kicked it off at some point. Anyway. All right, so questions on the assignment 4? Okay, so under, tried to keep it all together so it wasn't scattered all over the place. Under item 4, the lecture media. And then towards the bottom is the engineering analysis. The next one down is your files. So, you know, again, the intent was to give you try to take SolidWorks out of the mix as much as possible, so that you're not having to do the setting up the views and all those. If you want to do different views, if you want to set up your own, you're more than welcome to, but that gets you a start and gets you a jumping off point. So I'd be glad to help you with the way that they use it. Everybody's going to see it a little bit different. I'm just looking that you follow the basic logic, that you're able to apply those tolerances in a reasonable kind of a direction. And one of the things that I tried to emphasize too is very few people are designing in a vacuum. So you're always going to have the input and other people's input on the design review, going through the process. And so getting numbers on there, thinking about what it is that you want these parts to do and how you want them to fit together, that's the important part. Right? The actual technical, nobody sits down and memorizes the standard, except for the people probably creating the standard. Right, so as much as I've read the standard this semester and reread it to make sure I got my head wrapped around it, I'm probably going to read it 10 more times before we go again. Right, and then also mentioned if you are interested in SolidWorks for fall, that class is showing us closed. Get with Cesar, or let me know, and we'll get you set up. If you're in and you want to go on with track 2, let me know. I'll add you as an observer to the fall class, and you don't have to sign up or do anything special. My main goal, I don't know if it's our goal, but my main goal is to get you ready for that CSWA. And if you want to go on and take the professional at some point, I'm glad to help you out with that. Everything up to expert is on a voucher or somewhere available for free. And the professional recommends 2 to 3 years of seat time. You need to see a wide variety and consistent, steady design. And then this kind of rolls over into the drawing side, being able to apply this. There is I have to go back and look. There is either an associate, I know there's a professional level drawing that can tie in as far as another certification. So, all right, so next week, I'll try to add a little bit more. If I remember the tools and we again have the interest to go out in the machine, we'll probably do a little bit with the fixture. And I don't know. I probably have the plug-in, but I don't have the connector. I was going to say I needed to copy them over. The second lander drop was on Monday, and so the pulleys, once I changed the cable and we kind of did that simulation and was able to allow them to rock up so the cable wasn't coming up and over the spacers, they worked pretty darn good. And so they worked good enough that when we put the lander and went to pull the release string, if you didn't have a hold of the cable, the spring pressure was more than the pulley pressure, and it would pull the part back. So we had to hold on to the cable to make sure it didn't jerk when we pulled the string. So I think they did 14. There was 11 teams. We did all 11 teams in about 15 minutes, and there was enough time for 3 more teams to do a second try. They didn't destroy their lander enough to not want to drop it again. So I'll throw the pictures up if you're interested in seeing it. It is kind of neat to see how everything ties together. And when we talked about the loading and we talked about how the tolerances are being affected, and it's in function. And I still need to make another pulley because I am noticing that the side that got too thin is definitely deforming and is not going to last forever. So anyway, stick around if you have questions. I will. Otherwise, I'll see you next week. I would have sworn I hit record.
Alright, I'll text you later.
Either that or just record it. See it.
Do you think working on track 2 would be good? Because I kind of want to track for the CSWP.
All right, awesome.
But,
Track 2 is, I would say, in between.
okay.
And so the CSWA is kind of a it's good practice, but the CSWP is you're going to probably I would say realistically you're going to take it more than once.
Okay.
When I took the CSWA, I'd been using SolidWorks for about 6 or 7, 8 years, and so it was like, oh, an hour, 3-hour test, I'll do it in 90 minutes and have fun. The CSWP, both times I took it because they did it once as a full 3-hour. Now they have 3 45-minute or 3 50-minute sections. I took it both times, and both times I used all 180 minutes. And at the end of it, it was, man, what did I miss? What did I overlook? So, be prepared for the challenge. But
Yeah.
track 2 will take you up, and then the technical drawing portion of it. Most everything, I don't have the book, but the technical drawing book, the drafting book,
Yeah.
that those are pulled from, almost, I say almost all of the part examples for the test come out of that book. And then they throw in a few more things. So I'll look for the link. I'll send you a link for the practice exam.
Okay.
And take the practice exam and then go through track 2. So I'll add you.
Okay. That'd be cool.
Since this class will probably still remain open, but as people complete, I think it's going to be better that I think on the 10th or 11th of May is when I'm planning on opening up the fall class,
Okay.
and I'll add you to that.
Okay, and then I can start working on it.
Yeah, and then let's see. Do you want to start before then? Are you ready to go, or do you want to finish out everything you're doing this semester and then jump into it?
Yeah, I think I'll finish what we're working
Okay.
on.
Because Joe's favorite comment when he looks at any of them, but track 2 especially, is "I hate you." So I'm hated.
Yeah, I want to try it.
All right. Yeah, when it's going to be one of those when you look through it. The Cranium Cafe is new for the last. I've used Canvas very much.
Well, I have that. I don't really know.
Since
what
since the first of the year is when we really tried to use Cranium Cafe, and so it's one of those. I can show you my screen, or you can show me your screen, and so we can share screens.
Show you what's going on.
So it's kind of like Skype, but I don't have to hold the phone at my screen and try.
Okay.
It will show you what's going on, and as we put as you're pushing buttons or as you're moving around, and then it's that chat thing. So depends on how fast the connections are, and a couple other things. We've used it. A couple people has just been chat's not working, call on the phone and chat on the phone while they're doing whatever on the screen. So that's available to you if you want to. You get totally painted into a corner and you're ready to throw the computer at me. Then shoot me an email. We'll set up a cafe and get you pointed in the right direction. But they get progressively harder. It was never intended to be easy.
Okay, that's good. I like it.
Okay. All right.
And then for this class, I'm probably going to need the extension because.
Okay. Yeah, it's
like,
just like.
I think I forgot to turn in the first part or assignment, but I'm like, I don't know how far I am on the pulley.
Yeah.
But
so if you're watching the videos, and so the pulley, I tried to take it into tolerance analysis. Tolerance analysis just doesn't do what I want it to do. We can get basic numbers out of it, so I did not make an assignment for tolerance analysis. So the assignment is to go through the drawing and apply the dimensions, the GD and T, and then go back to the parts like we did early on in this one, do the DIM expert and see what the software found that was different than what you created or that we created going through the process. And then the whole thing about the assignment 4 is to take those 9 sheets, and basically what I did in that video is go through each one, think about what you want for tolerances, apply the dimensions, and then apply what you think are basic dimensions, build it up from there into the form tolerances, build it up to the next level, build it into each of, refine it as you go. It's not a go through and make it perfect the very first time.
Okay.
And then grab everything, zip it up, and upload it to Canvas.
Okay. I'll turn to the first one. I did
All right.
finish that.
All right, we'll set you up.
Okay. Thanks.
Is that going to affect your graduation, or you have one more class this fall?
I have one more to take.
Okay, so it's not going to screw up your graduation.
No.
Okay, good.
But I'll probably keep taking classes actually, because there's one at Gateway I want to take about, I think it's called tooling and fixturing.
All right.
I want to take that, and I kind of want to take another CAM class because,
Yeah.
like, I really like Chris for the second one, but
Yeah.
I feel like he doesn't have time. He didn't have time to prepare, so it's
Yeah.
like it's kind of a bit of a
That's where I'm at. I feel like this class was I
because
started.
this is a new class too, right?
Yeah. I started with it was the first week was, or the week before, we had 6 people, and then all of a sudden there was 13 people. I was like, oh. And so the direction was, trying to fill out where everybody was at, and not everybody was prepared, and not everybody had what I thought they should have to get here. So I did a lot of backtracking and backstepping. The multi-axis cam I have fun with. All of the solid modeling cam I have fun with. So take as much as you can. You can never go wrong with it.
So I'll probably never move down to school. Because then I was also thinking, like, after that, I want to try welding. I don't know.
Perfect.
It's like maybe something else too.
Curtis Casey and Bob Holmes are in the SolidWorks class on Thursday nights. If you want to talk to the welding guys, they're here.
Maybe Thursday.
Yeah, tomorrow night's the advisory committee meeting.
Oh,
So I
yeah.
don't know if that's.
I forgot Joe asked me about that, but I'm not going to go.
Oh, okay.
He wanted me to talk.
Oh, yeah. Don't show up then. He'll make you talk.
I don't want to.
I had such a wonderful time in the machine program.
Because I was telling him I was kind of disappointed in the CAM classes how like unorganized it was. And then he asked me, I was like, I'm not going to like talk about that for all those people.
Yeah.
I don't know. I'm not going to do it.
Now, so the multi-axis, everybody has their own views of what they think is important. So I think the 3-axis is probably more important than the 4th and 5th. If you get a good handle on the 2.5 and the 3-axis, being able to manage the 4th and 5th is a lot easier. I don't know. And like I was trying to show tonight, is each one has their own quirks and temperament about any of the axes and any of the turning and any of all of this. So.
Okay. I'll
Good
see
night.
you.
Oh man, I can't believe that didn't record. It's still launching the recorder, so you hung up. Where are you? What are you doing?